Hey guys, this is Jose and this is tutorial number 9. Um, as I mentioned before, we're gonna make a tutorial on lists to see what is the functionality of them and how they operate. So we're gonna just focus on that. It's gonna be also a very short tutorial, but I think it's gonna be very handy. So I'm gonna just write here. We're gonna do a few operations of this. Um, I will point out, probably in the Vimeo account or on the YouTube channel as well, um, some other tutorials that are really good on lists, because lists are generic to Python, and but I think that there's really good material out there as well to just get to understand lists better. Having said that, we will do the basics. So what is a list, right? We're gonna do a list that is gonna be basically a collection of elements. If you're familiar with processing or with Java, you will know that we have arrays or array lists. I would say that lists, in a way, it's kind of a mixture of both. Because they are dynamic, they can basically change the number of elements and the elements that they contain. Um, they have a lot of other interesting operations as well. So let's see like an example of that. So we define them with a square bracket, like that. So basically, that would be an empty list, right? So if you say something like print my list, you would see that you're just printing, in this case, this element, meaning something empty. Um, let's put some stuff in here. So let's put something like 54, 22. So we have a few elements inside. And again, if we print it, we'll see that those are the ingredients inside the list. But the interesting thing about lists in Python is that they can contain different kinds of elements. So we could have something like a string, right? In this case, cat as a word, specifying with these columns that quotation marks, sorry, that that this is a kind of a string of letters. So you could see that the list operates fine. It doesn't ask us to have one specific kind of value. In this case, we are having integers, strings, and now I'm adding a float. And okay, this is interesting. And you can see how this list is operating, right? So let's start using some of the functionality that the list can give us, right? So how do we add a new element to a list? If we have this list that we obtained somehow, like maybe through some Rhino operation, we can add elements to that list. So we can do that by saying my list. I'm just gonna copy it. Dot append, and then we can append any element. And this element that we will add to the list would be basically at the end, right? Um, so in this way, we are actually adding elements to the end of the list. And that's something that you will be doing most of the time. Perhaps maybe if you want to do a line or a curve, you're going to start making an empty list and then just going through certain calculation and adding that element, appending that element to the list, and at the end of the loop, perhaps you will make such a line with those ingredients, right? Um, one other thing that we could do, let's say if we had two lists, I'm going to rename this list to my list 01, and I'm going to copy it and paste it, rename my list 02, and I'm going to change the ingredients to something like 8, dog, 33, right? I'm gonna at this point I'm gonna just comment out this line so we can have it as a reference, but not as the one that we will actually use. And I'm gonna say something like my list 1 dot extend my list 2, right? So let's see what this line would be doing, right? And we're gonna print it out as well. So just no such thing as my list. Nice mistake there. Right. So extend is saying add all the elements of list 2 to list 1, right? So that's also quite interesting. If you're familiar with Grasshopper, these are kind of some of those operations that are in the lists command. And let's see a few other that might be a little bit more tricky in the way we have to understand them. Because they operate differently than in other scripting languages, right? So, for instance, if we say something like my list or one now dot remove, and here the function remove is asking us like, what do you want to remove, right? Python is asking us what element here do we want to remove. In this case, we have to specify the actual ingredient, let's say 54. Remove 54 from this list, and it's working, right? I say that it's different because for instance, in Java or other scripting languages, you might want to say, I want to remove the first element of this list, and we'll see how to do that as well, without really knowing what that element is. So what is that element? This is the element number 0. That's the index of the element. And this is number 1, and this is number 2. So we have 3 elements as a total, but we start in 0. This is the element 0. That's very important to understand, right? And so if we try this with 32, you'll see that we can remove from the list any of the elements inside that. And as I said, how do we actually remove the element 0, the first element of the list? So we could say something like my list01 dot pop element 0. And let's see. Right. So this line is doing exactly the same that this line if we would have put the 54 there. But this one is saying I don't really care what it's in there. I just care about removing the first element of this list, right? And this is very important because most of the time, especially with geometry, you won't know what it's inside the list. Let's say there would be a point or a vector or something that you won't be able to use remove and give the specific values of that vector. You want to remove the index value, right? I mean, by the index value. The other interesting thing is that this pop function actually returns this 54 in the form of a variable, right? So if we say something like print x, we can see that pop not only removes 54 but actually takes it out, and it allows us to create a variable with that value. That's also very interesting. So I was actually like, when I jumped into Python the first time, I was just looking, it's like, how do I count how many elements do I have in my list? And I was constantly doing for loops, and just needing to know how long the list was. The thing is that Python doesn't really need, you don't really need how long a list is to do a for loop, because you can do a for loop by saying for I in my list, something like that, right? So basically you will go through the elements, each one of the elements in the list, without having to specify the length of the list, right? But that's just another issue. But there is a way of actually finding how long your list is. If you're calculating something, you're kind of, let's say, searching through some geometry and with some criteria, and you want to count how many points you keep adding these elements, let's say, to a list, and then you want to count them. Well, there is a function, you could say print line the length of the list, right? I'll remove that one. So len parenthesis list will tell us that there are 3 elements in the list, right? So that is the way in which you would find out how long the list is. And there's one more, as we're talking about indexes, and this is perhaps the most important thing, that we will be working with lists and indices all the time. Every kind of Rhino operation that we do will return us a list, with where the index 0 would be something, in the index 1 would be something else, and most of the Rhino commands return lists. So we have to be ready for that. Let's use the index command now. So we're going to say print dot my list dot index 0, right? So, oh, sorry. This is what is perhaps interesting of this index command. Here, what we say in index, we say basically what is the index of cat, right? The element cat, what is its index? And it's index 2. If we say 22, what is the index of 22? We're asking print the index of 22, and it's number 1. And if we put 54, we'll get the 0, right? So again, here, like, we can actually, there's one more thing that perhaps we can mention. If we have just numbers, I think, 66, 77, 3, we could say something like my list dot sort and print list of 1 dot sort. Right. So sort, we need to add these parentheses for sort to work, right? So if we right now, we'll see that the same list that we had before now has been sorted. It has been organized with a smaller number. At the same time, we could say something like my list 1 dot reverse, and then we have the inverted version of that sorted list, right? So I think that it would be still better to just work with as we're working with examples. You will start getting more understanding of lists and how they're used within the Rhino syntax. But just as a reference, I wanted to go through some of these ingredients, some of these functions that lists can offer, so we can have the base to move forward. That's it.